Hi, in this lesson, I'm going to show you the relationship of hypothesis testing and confidence intervals. After this lesson, you will see that you can actually use confidence intervals in place of hypothesis testing. But there are also studies in which hypothesis testing is the best way to use, especially if you just want to test a certain hypothesis. Remember that the main use of confidence interval is to make an estimate of a certain value. And here in this video, we will be connecting the two. Now let us start with a general idea. You should know that when you consider using the hypothesis test together with the confidence interval, there is a correspondence that you have to follow. If the hypothesis test is supposedly a two-tailed test, you have to use a two-sided confidence interval. Now, however, if the test is assigned as one-tailed test, then the confidence interval that you have to use should be a one-sided confidence interval. For two-sided confidence interval, we will have both the lower limit and the upper limit L and U. While for one-sided confidence interval, we only have one of those two limits. It could be either the upper limit U or in another case, it could be the lower limit U. That is lower limit L. That is why we say it's a one-sided confidence interval because there's only one side, either the right side or the left side, that is to be computed, the upper limit or the lower limit. Also notice that from the one-sided intervals, one of the sides of the interval contain infinity. That is, if we are using or we are only considering the upper limit, then the other side must be a negative infinity. It means no boundary up to a certain level or certain value u. Now on the other hand, if we only interested to find the lower limit, then the other side has no boundary, so that is why we have until positive infinity. Now recall that the decision to choose between a two-tailed test and one-tailed test will depend on the alternative hypothesis. The two-tailed test is used when our alternative hypothesis follow the format, let's say a parameter mu is not equal to a hypothesized value. While for the one-tailed test, you will have the following alternative hypothesis. One is that mu is less than the hypothesized value, or the mu is greater than a hypothesized value. Now in the case of mu not equal to mu sub 0, it is easier to see that we have to compute both the lower limit and the upper limit so that we can see what interval contains the true value of the parameter. Now, for the less than and greater than alternative hypothesis, if the mu is less than the hypothesized value, we need to know what exactly is the highest possible value that the mu can be, because it is already less than mu sub 0. Let's say if this is a number, if this is mu is less than 6, we say that the value of the mean is not equal to 6. So we have to know what is that highest possible value that we can have. So we use the upper limit. Now if the alternative hypothesis is mu greater than mu sub 0, that means it should be higher than the specified value. Then we have to check what is the lowest possible value that we can have. Therefore, we use the one-sided confidence interval that requires the value for the lower limit. Now, maybe for now it doesn't make sense yet because we still have to see an example, but this is the general idea relating the hypothesis testing and the confidence interval together with the alternative hypothesis. So to understand how these two are related, let us use an example. Let us use an example that will require a two-tailed test. Suppose that you want to conduct a study and your topic is about the average family size in a certain city. So if you will be checking related literature or any related studies, you might find out that the existing status quo is that the average family size is around 5. So we can set, so in this study, we can set the mu to be equal to 5. And that means our question is, if that is the status quo, then after some time, can we still consider that to be the mean? Will it still be mu equals to 5? So we will be challenging that with the alternative hypothesis that the mean is no longer 5. So as we know, an alternative hypothesis with a not equal to a number will require a two-tailed test. Now let's say you have conducted a survey, you have selected 50 respondents randomly, and when you ask them about the size of their family, the average of those values is 4.15 and the standard deviation is 2.76. And then in the study, let's say you decided to use an alpha equal to 5%. So again, as we know, we will be using a two-tailed test which follows the formula z is equal to x bar minus mu sub 0 over the quantity, the standard error s, over the square root of n. So if we will use the values that we have in the based on the survey, this is the number that we will get, the negative 2.18. Now based on our diagram, let's just say that you have followed the steps, you check the value that you obtained, the negative 2.18, and it fell into the area of rejection. So that means the decision is to reject the null hypothesis, and that there is sufficient evidence that supports the alternative hypothesis, and that is the average family size is not or no longer equal to 5, and this is at 5% significance level. So as we can see, the process that we used through the hypothesis testing was able to conclude that the null hypothesis must be rejected. Therefore, we know that the mean, the average family size is no longer 5. But that's the only thing that the hypothesis test can provide us. We just know it's not equal to 5. But what is really the number? Is it higher than 5 or is it lower than 5? So from the hypothesis testing, we cannot know a value. But there is a tool that we can use to estimate that value, and that is if we use the confidence interval. So as you can see, this is where we use the confidence interval in relation to the hypothesis test. Once that we have made a conclusion, we might want to extend our study to know what could be the possible value for a certain average. And in this case, if the mean is not equal to 5, what could be the value for the mean? Is it higher than 5? Is it lower than 5? So we will use the confidence interval. Now, the confidence interval is something that you have learned prior to hypothesis testing. So all we have to do is to recall how to find a confidence interval. Now let's just start with the confidence interval that uses the value of the z, because there is also a version that we use for obtaining a confidence interval using a t, the other value that we use. So let's use the same problem because this is what we are going to relate. So first, we need to recall the formula in finding or constructing the confidence interval, and that is the value of the mu is somewhere between the value of the sample mean plus the margin of error, z of alpha over 2 times, well, it should be sigma if sigma is known, but if the sigma is not known, we can use the s. And then on the other side is the x bar minus the same value, z of alpha over 2 times s over the square root of n. And we all know that this formula can be changed into a simpler form, and that is the mu should be somewhere in between x bar plus and minus z of alpha over 2 times s over the square root of n. And let us find the corresponding confidence interval with the study that we use in the problem. So let's go back and see the information that we have. The n is 50, x bar is 4.15, and s is 2.76. Now, one very important thing to note when you relate hypothesis testing and confidence interval is the significance level and the confidence level. In the hypothesis test that was performed in this problem, the level of significance alpha is 5%. So if you will relate your hypothesis test to a confidence interval, then you have to select the confidence level corresponding to that significance level. So if the significance level is 5%, then it must be using a confidence level related to 5%. So the confidence level that we have to use is 95%. So when we do that, we will be able to preserve the alpha that we have to use for the confidence interval. If we have 95% confidence level, then the alpha is 5%. So the alpha over 2 that you have to use here is 0.025 or 0.05 divided by 2. Let us now compute for the confidence interval. So we have x bar, again, is 4.15 plus and minus the z of alpha over 2. Now the z of alpha over 2, which was already obtained in the hypothesis test, and that is 1.96. So this will be plus and minus 1.96 times the standard deviation of 2.76 divided by the square root of 50, which is the sample size. If you compute for the value, what you will get is 3.3850 for the lower limit and 4.9150 for the upper limit. So this estimates the value of the mu, and that we know that it is no longer equal to 5. So the estimate of the value is somewhere in between 3.3850 and 4.9150. Now take a look at the confidence interval that we have formed through a 95% confidence level. Suppose that we didn't perform the hypothesis testing, but we instead constructed the confidence interval immediately. Now, based on the information that we have gathered some information. If we estimate the mu will be given by the confidence interval, and that we know that 3 or the value of the mu should only be from 3.3850 and 4.9150. So if someone will claim that the mu is equal to a certain number, and that is 5, then we can say with our confidence interval, with 95% confidence level, that this is not correct. Because 5, this number, is not among the possible values as suggested by the confidence interval. So here you see, aside from estimating a number, it can actually, or the confidence interval, can already make a conclusion about a certain hypothesis. And that is by checking where the value is in the given interval. If it is outside the confidence interval, then it is not a possible value. And since this is our null hypothesis, that mu is equal to 5, that is not possible anymore with the information that we have gathered. Okay? So I hope you were able to see that special relationship between a hypothesis testing and a confidence interval. That if you skip the hypothesis testing and you come up with a confidence interval, you can still check whether you can reject a certain null hypothesis, like what I have shown in this example.